right here. We already know, because you've done this before, you took a quiz on it, that you can take standard form and convert it into vertex form. But the method I'm going to show you now is by doing it with completing the square. Okay, so then what you gotta first look at is this here almost looks like a perfect square trinomial. Because think about it, if we have x squared plus 4x, okay, we could continue that to be a perfect square trinomial right here by just taking the 4 and halving it to get 2, but then squaring it to get 4, right? Then it would be a perfect square trinomial. So that being said, if only I had a positive 4 instead of that positive 3, then I could convert it to a perfect square trinomial. Okay, so let's think about that. What is this right here? Is this here statement equivalent to this here statement? Look at your terms, simplify them, and ask me, is it equivalent to this right here? Yes. So, in other words, even though you see that it is clearly a plus 4 that's been stuck onto this, and then a minus 4, it doesn't change the value of the expression. Now, let me ask you this. If I took this expression right here and grouped it where the first part right here is just set aside in parentheses and then left this part here on the end, what do you notice about this trinomial? Can we factor it? Can we factor this trinomial? Maybe we should go back to this the question.
Wait, yes.
If you have a perfect square trinomial, then that means you have a trinomial where your last term, when you take the square root, is double the term in the middle. Okay, so let's look at this here. If I take the square root of 4, it's 2. When I double it, I get 4. So is this a perfect square trinomial?
Yes.
If it is, then that means I can factor it and rewrite this portion here as just x plus 2 squared. Well, from there, I'm changing this to x plus 2 squared. Where do you think the minus 1 came from?
The negative 4 plus 3.
Good job. It comes from negative 4 plus 3. Look carefully at step 3. This is vertex form. All I would have to do is stick a y on here. And I have x plus 2 squared minus 1. If this is in vertex form, we're given a vertex. What's my vertex?
Negative 2, negative 1.
This is where I was on the fence about using this method of explaining because it's kind of confusing. So I would like to show you what I feel might be a better explanation of how to do this method than what they just showed you. I will use a lot of color coding, so stay with me here. If I wanted you to take these in standard form and make them into vertex form by completing the square, you would have to have a perfect square trinomial. Is this a perfect square trinomial?
No.
If we don't know what perfect square trinomials are.
Not.
It's not one, but someone said yes, which made me nervous. If it were a perfect square trinomial, this number would have had to have been what number?
25.
Nope, not 25.
36?
9. Oh, we're struggling. Let's go back for a second. Everything that we've done so far.
Oh, it would be 9 because 6 divided by 2 is
We half it, and then we square it.
Yeah.
Right. So then what I'm saying is this number here, that 5, is jacking it up because it's not a perfect square trinomial with the 5 in the way. What we would do is take our x squared and our 6x, group it together, leave a spot, and push the 5 out. And then you tell me again, please, what number should go here? What number should be in this little spot right here?
9.
Should be a 9. And if you don't know why, I'll show you why. You're dividing this by 2. And the number that you get, you have to square it. But when you think about an expression If I'm adding 9 here, I'm changing the whole value of my expression, and the only way to keep the value is if I take the 9 away here. Because look at the problem here. See how you had a +4 and a -4, and the expressions were the exact same? Well, that's what we're doing here. If I put a +9, I have to put a -9 so that I can keep the expression the same. Y'all, we're just transforming it and writing it in a different way. That's it, okay? So from here, I can factor the perfect square trinomial. This is factorable. How would I factor this? What would it become? X plus 3 squared. And then what would this right here give me when I subtract them? -4. Stick a y equals in front of this. You have just turned it to vertex form using the method of completing the square. It was x plus 3 squared minus 4. Okay, I showed you the first time. It doesn't always sink in, I know. But vertex form gives me the vertex. What's the vertex for this problem?
-3.
The vertex is -3, -4. Try the next 2 with me, and then you do the last one on your own. Number 2, is this a perfect square trinomial?
No.
Because this number 11 should not be there. What number should it be?
16.
Good job. So what we do is we kick this out and write x squared minus 8x, leave a spot, plus 11's outside. You just told me that this number here should be 16 because we take half, giving us a -4, but when you square -4, you get 16. Well, I'm adding 16 here, but I'm subtracting the 16 here to keep the expression the same. Now that I have done this, you have what we call completed the square. You forced it to be a perfect square trinomial. Factor this that I just highlighted. What would that be if I factored it?
X minus 4 squared.
Good job. Okay,
-5.
and then on the end, good job. This would be -5. Stick a y equals in front of it. You have just changed it to vertex form. Vertex form gives us the vertex. What is the vertex?
4, -5.
Okay, last one I want to do with you is number 3. This looks like it's a perfect square trinomial. It does, but it's not. My last class tried to argue with me.
Is it because they're negative?
It's because that should be negative, it should be positive. So this right here is my problem maker. That's what it'll be -4. What should it be? +4. Good job. Awesome. So then we're going to kick this out. I have x squared plus 4x. And then the -4 is going to be out here. You just told me that it should be a +4 because half of 4 is 2. 2 squared is 4. If I add 4 here, what do I have to do behind here? If I add 4 here,
Subtract 3.
I have to subtract 4 here.
3 0. Wait, never mind.
No, it would not. But you're now at the point where you can rewrite this in factored form. If you rewrite this in factored form, it becomes x plus 2 squared. And then simplify this. What do you get?
-8.
Good job. -8. Stick a y equals in front, or f of x, really, put that in between. And your vertex is
-2, -8.
Can you do number 4 on your own?